All right, in this video here, we're going to do a couple examples where we use the trigonometric ratios to actually, evaluate some stuff. So I'm given a triangle here with an angle theta labeled. The three sides of the triangle are labeled for me, and we're asked to find the 6 trig ratios of the angle theta. Right, and I put them up here, and also put up, SOH CAH TOA. If you didn't watch the video that I did on the definitions of the 6 trig functions in terms of the ratios of the sides of the right triangle, I would advise you to check that out before you watch this one. This one I'm just taking the definitions that we talked about in that other video and actually just using them to do a couple examples. All right, but if you don't know what those definitions are, then what I'm about to do here may not make that much sense. All right, so first off, with my triangle, first thing I want to do here is label my sides as far as which side is the opposite, which side is the adjacent, which side is the hypotenuse. And I'm going to start with the hypotenuse because that's usually the easiest one to identify. Across from my right angle, so here's my right angle, right, the one with that little box there. Across from that is the 3. That's going to be my hypotenuse. So I'm just going to put an H next to it so I know that that's the hypotenuse. All right, here's the angle theta that I'm concerned with. So across from that angle theta, the 2 is going to be my opposite side. So I'm going to put an O there for opposite. And then the other side, the side that's next to my angle theta, is the adjacent side. So that square root of 5, I'm going to label with an A for my adjacent side. Right, so that's how you can figure out which side is which as far as opposite, adjacent, hypotenuse. Hypotenuse is always across from the right angle. The opposite side is across from the angle theta that you have labeled. And then the adjacent side is just the other side that's there, the one that's next to your angle, but not the hypotenuse. Right? All right, so for SOH CAH TOA, to find these 6 trig ratios, sine of theta, and what that SO means, sine is the opposite over the hypotenuse. Right? That's what that SOH means. Sine is my opposite side over my hypotenuse. So sine of theta, the opposite side is the 2, and the hypotenuse is the 3. So sine of theta equals 2/3. That's it. Right? When you have your triangle labeled and you know the O, A, and the H, the opposite, the adjacent, the hypotenuse sides, and you know these definitions, all you have to do is take the sides of the triangle and put them into the proper fraction, the proper ratio, and you have sine of theta. Right? You don't need to know what that angle theta is, whether it's 30 degrees or 46.3 degrees. It doesn't matter. Right? If I know these 3 sides of the triangle, I can find sine, cosine, tangent of theta, and all the other ones as well. Right? Cosine of theta, CAH, right? Cosine is the adjacent over the hypotenuse. So my adjacent side is the square root of 5 over my hypotenuse, which is 3. Right? So cosine of theta equals the square root of 5 over 3. Right? That's it. Tangent of theta, that's my TOA, right? T for tangent, O is the opposite, A is the adjacent. So tangent is the opposite side, which is 2, over the adjacent side, which is the square root of 5. Now, as happens a lot with when we're evaluating trig functions, a lot of times we end up with those roots, those square roots in the denominator. So I want to rationalize my denominator here by multiplying both the top and bottom by the square root of 5. And I did a video a while back about rationalizing denominators, so if you don't know what I'm talking about there, find that video I did on rationalizing denominators and you'll see what we're talking about. But when I do this, I'm going to get 2 times the square root of 5 over 5. Right, so that's my value for tangent of theta. All right, so those are my first 3, my sine, my cosine, my tangent. If I do SOH CAH TOA and I know how to identify the 3 sides of the right triangle, all I'm doing is taking the numbers from the sides of the triangle and putting the right one on top and the right one on bottom. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is the opposite over the adjacent. That's really all there is to it. Now, sometimes it can get a little more complicated, like if they only give us 2 of these sides and we have to figure out the 3rd side. But we'll get to stuff like that, and it's really not that much more difficult than what we're doing here. All right, so once I get those first 3 sides of the first 3 trig functions here done, remember, to do the other 3 are just reciprocals of the first 3. So I don't have to know the definition of cosecant, secant, or cotangent. I just have to know which one is a reciprocal of which. Right? And sine and cosecant are reciprocals of each other. So if sine of theta is 2/3, cosecant of theta is going to be 3/2. Right? I just take the answer for sine, I flip it over, that's my answer for cosecant. Right? Pretty simple if you know those reciprocal relationships, which I did another video in the past where I talked about the reciprocal relationships of these. It probably came up actually in a few of the videos I did talking about the unit circle trigonometry. So you can find those there if you need to find them. Cosine was root 5 over 3. Secant theta is the reciprocal of cosine theta. So secant is going to be 3 over the square root of 5. Now, once again, just like we have with the tangent here, we get that square root of 5 in the denominator. So once again, I need to rationalize my denominator by multiplying the top and bottom by the square root of 5. So I get 3 square root of 5 over 5. All right, so secant of theta is 3 square root of 5 over 5. And then cotangent of theta is going to be the reciprocal of tangent theta. Right, so I'm not going to take the answer, though, that I got for tangent theta. I'm going to go back to this original one that I had here, 2 over the square root of 5. If I just flip that one over, I get the square root of 5 over 2, and there's my cotangent of theta. Right? If I take my final answer for tangent and I flip that one over, I put in that square root of 5 back in the denominator, and then I have to rationalize it all over again. Let me just go back to the original. When I flip it over, that square root of 5 actually goes to the numerator, and then I can just leave it alone. Right? So, be a little smarter there. If you had to rationalize in one of these, when you flip it over, go back to the original, not the one where you rationalized it. All right, so those are the values of my 6 trigonometric ratios for this particular triangle and this particular angle theta. Right, so that's it. But when you have the triangle there and you know which angle you're talking about, just identify opposite, adjacent, hypotenuse, and then just know your definition. SOH CAH TOA. The definition for sine, cosine, tangent, and then you just take your numbers and put them into the fractions, and that's all there is to it. And then the other 3, you're just flipping over the first 3. All right, I'm going to pause the recording here and erase this first example. I'm going to put up another example where we do something similar working with these trig ratios. All right, next example. If cosine of alpha equals 3/4, sketch a right triangle with acute angle alpha and find the other 5 trig ratios of that angle alpha. All right, so first thing, this symbol here, which kind of looks like the letter A and also looks a little bit like a fish, that's the Greek letter alpha. We also use that sometimes for angles. So we use the letter theta, the Greek letter theta, which is the circle with a little line through it. We also use alpha sometimes for angles. We also use beta, which looks like a R capital B. So when we're dealing with angles, a lot of times we do use Greek letters to represent those angles. I really don't know why we do that, but that's just conventionally what mathematicians do. So as you go further and further along in math, you learn more and more of the Greek alphabet as you go. And if you take physics classes as well, and a lot of the formulas they use Greek letters. So by the time I finished going to school, I knew most of the Greek alphabet, never having actually studied Greek before, just from math and science classes. But anyway, that's totally beside the point. So cosine of alpha equals 3/4. So I want to sketch a right triangle. So let me start by drawing a right triangle. All right, so just a triangle with a right angle in it, and let me label one of these angles alpha. And I'll put the alpha as the one down here that's in like the standard position. If you didn't watch the videos that I talked about standard position of an angle, but this is it, right? So this is where our angle alpha is. Now you could have also labeled that angle up there alpha if you wanted to. It doesn't really matter, but most of the pictures we see, the labeled angle is the one on the bottom left, so I'm just going to kind of keep it consistent by doing that. All right, so cosine of alpha equals 3/4. So now I need to label the sides of my triangle. Now they tell me what cosine of alpha is equal to. So remember, our SOH CAH TOA thing. All right, so for SOH CAH TOA, cosine is the adjacent side over the hypotenuse. Right, so my hypotenuse would be this side over here, right, across from the right angle. My opposite side would be over here, across from that angle alpha, and my adjacent side would be the one down along here. So if cosine is the adjacent over the hypotenuse, and cosine of alpha equals 3/4, well then 3 is going to be my adjacent side, and 4 is going to be my hypotenuse. All right, so my adjacent side is 3, and my hypotenuse is going to be 4, because cosine is the adjacent over the hypotenuse, and we know that cosine equals 3/4. Right, so it's another type of problem than the one we did before. The last example we did, they gave us the 3 sides of the triangle and just said find all the 6 trigs, sine, cosine, tangent, and so on. Find all those ratios. This one, they tell us one of the ratios, and it's up to us to figure out what the triangle looks like, and then also find all the other ones. Right, so this one is a little bit more work for us to do. The first thing we have to do is actually build the triangle. Right, so the triangle, I'll put my alpha here. Cosine is the adjacent side over the hypotenuse side, 3/4. That's what cosine of alpha is equal to. And now I need to find my opposite side, though. Right, so to find the opposite side, something else that maybe you know from geometry, something we call the Pythagorean Theorem. Right, for the Pythagorean Theorem, if I have a right triangle, let me just real quick draw one here, and the sides are A, B, and C, right? A squared plus B squared equals C squared, right? The sum of the squares of the two legs of the right triangle is equal to the square of the hypotenuse, right? So when we're dealing with right triangle trigonometry, we do have to use the Pythagorean theorem quite a bit. Basically, anytime we know two sides of the triangle and we need to find the third side, we're using the Pythagorean theorem. Now remember, that's only for right triangles, right? The Pythagorean theorem does not apply if we don't have right triangles. And I'll be doing some videos sometime soon where I talk about how to do trigonometric stuff with triangles that are not right triangles. It gets a little bit trickier to do those. There's like more complicated formulas you have to use there, right? But in this case, my if I call this side x, the missing side that we don't have, right? So 3 squared plus x squared is going to equal 4 squared, right? Be careful when you're doing this Pythagorean theorem. I've seen a lot of students make a mistake in the past where just whatever two sides they have, they'll do like 3 squared plus 4 squared equals x squared. Remember, it equals the hypotenuse squared, and my hypotenuse here is 4. So that 4 squared has to go on the other side of the equal sign from that x and from the other sides, right? So make sure you're putting each one in the right spot there. And then if we solve this, we have 9 plus x squared equals 16. If I subtract the 9, I get x squared equals 7. And when I take the square root on both sides, I get x equals the square root of 7. All right, so that's solving a pretty basic quadratic equation there. I mean, it's an x squared, but you just square everything, subtract this to the other side, take the square root, and you've got your value for x. So now we know the values of all three sides of our right triangle. All right, so now I know the adjacent side, the hypotenuse, which we were given, and I just figured out the opposite side. Right now, if I want to find all the trig ratios, now I can just do like what we did in example 1 a few minutes ago. Right, once we know all the sides, then it just becomes example 1. So sine of alpha, sine, right? So sine is the opposite over the hypotenuse. So the opposite is the square root of 7 over the hypotenuse, which is 4. All right, and after I do sine, let me just go ahead and do cosecant of alpha. Since cosecant is the reciprocal of sine, cosecant is going to be 4 over the square root of 7, right? So to get cosecant from sine, I just flip it over. Since it has that square root in the denominator, just like we saw in that last example, I multiply by root 7 over root 7, and I get 4 root 7 over 7. That's going to be my value for cosecant of alpha. All right. Cosine of alpha, well, that's my adjacent over my hypotenuse, which is going to be 3 over 4, which it ought to be because that's the very first thing we were told in this problem is that cosine of alpha equals 3 over 4. So it's good that after we did all that work, we end up with the same thing. If we got something different here, it means we totally screwed up this problem and we either quit or we go back and try to fix it. I would advise going back and actually trying to fix it. But that's just the teacher and me talking to you here. So cosine of alpha equals 3/4. The reciprocal of cosine is secant. And so I take the reciprocal of 3/4. Secant of alpha is going to be 4/3, right? I just flip the fraction over. Right? Tangent of alpha, tangent is the opposite over the adjacent, right? That's what that TOA means, opposite over adjacent. So my opposite is root 7 over my adjacent, which is 3. All right, so tangent equals root 7 over 3. The cotangent of alpha is going to be the reciprocal of tangent, right? So the reciprocal of tangent would be 3 over root 7. Once again, there's a root in the denominator, so I rationalize it, and I get 3 root 7 over 7. Right, so that the last part of the problem there where I actually evaluated all the 6 trig ratios, I did that part a little bit quickly, but that's because that part is just like what we did in that first example a few minutes ago. Right, so if you understood that first example, you should have been able to understand me going through it a little bit quicker this time. For the second example, the major thing was, they told us cosine of our angle. I had to draw the triangle. I had to put the 3 on the adjacent side, the 4 on the hypotenuse, use the Pythagorean theorem to figure out that third side. And then once I do that, now I'm free to go ahead and use SOH CAH TOA to evaluate each one of those ratios. All right, so that's a couple examples of using these trig ratios. Again, really important to know the definitions, the SOH CAH TOA and what that means and how to label your triangles with the opposite, the adjacent, the hypotenuse, and then also knowing the reciprocal properties of those trig functions, right? So if you know all that stuff, then doing these types of problems is really not so bad. if you forget any of that stuff or you never learned it, and then doing these problems is really hard. So if any of that didn't make sense, I would suggest going back and watching some videos and relearning some of that stuff that you should have picked up along the way in order to be able to do this stuff correctly.